Hi, my name is Will Creighton. I'm a postdoc at Brown, and I do research at the intersection of programming languages and human-computer interaction. I'm giving this talk because I've been thinking a lot about the following question. How are we going to write our papers, blog posts, and textbooks, and so on, in 10 years' time? Like, in the year 2034, are we going to be writing academic papers with LaTeX to generate PDFs? Are we going to be writing blog posts with Markdown using static site generators to output HTML? That's certainly how we're doing it now. That's pretty much how we did it in 2014, and it's not too different from how we did it in 2004. Now, I'm using we in a somewhat myopic sense, like computer scientists and programmers. But I think that's a useful group to focus on because we are at the vanguard of document technologies. And I think the way that we write technical documents needs to change. And right now is the right time to think about this question. To convince you of this, I'm going to start by laying out a sequence of observations about the world, just different things that I've seen in the last 5 years that all come back to this core theme. So, the first and most important observation is that the average technical document is plain words wrapping static figures. By technical here, I mean documents whose main goal is to transfer knowledge, as opposed to like stir an emotion or some more creative endeavor. And by plain words wrapping static figures, I mean stuff kind of like this. This is a passage from a book I've worked a lot with recently. It's an online textbook that teaches people about the Rust programming language. And so you have static figures, like this code snippet, and then a ton of words about it. Stuff like, this program first binds x to a value of 5, then it creates a new variable x by repeating let x equals, taking the original value and adding 1, and oh my god, who wants to learn Rust after this? But this is the standard of technical communication. Nearly every technical document in the world looks like this or worse. And this has been true for centuries. Our method of communicating technical content is basically unchanged. Now, some people have tried to write better content. Like Distill was an online journal for articles about machine learning with a specific focus on high-quality explanations and visualizations, such as the one on screen. And Distill was an amazing resource, but then they shut it down. Why do they call it quits? Because, they say, we didn't believe anymore that having a venue was the primary bottleneck to people producing more Distill-like articles. The primary bottleneck is the amount of effort it takes to produce these articles and the combination of scientific and design expertise required. So I find that troubling. But, maybe we could just take the documents we know how to write and modernize them or something. We've actually tried that. It's called the ACM Publishing System, or TAPS. This is the ACM's attempt to modernize their publication stack for the digital era. And a cornerstone of that approach is converting everyone's LaTeX documents into HTML. And that has not gone great. So first, the ACM said you can only use a white list of packages vetted by the development team. So sorry if you use any niche category theory package that they haven't thought of. And then they started to say that you can't use macros at all. The whole PL community was in an uproar over that. And it's subtler, too. Like, they do a lot of automatic conversions of rich figures into static images that can lose important accessibility information. So, if LaTeX isn't the answer, what is? Well, almost every new document language is some variation on Markdown. Here's just a few. MDX combines Markdown with React JavaScript. Quarto builds on Pandoc to design a notebook-oriented publishing platform. Stripe added a preprocessor to make MarkDoc for their documentation. Living Papers from Jeff Heer's group at UW also builds on Pandoc to support reactive documents. And so, if we just ask descriptively, what is the next generation of document languages? Right now, it's ones like these. But this should concern you. There are some big issues with Markdown that have gone unaddressed in these systems, and we'll talk about that later. But I also want to note there's this little-known tool called ChatGPT, and you know what format of text it generates? That's right, Markdown. As people continue to use language models to explain things to them, there's a very interesting opportunity to think about how the document language beneath the LLM influences how people consume its content. And of course, people have been building cool tools for augmenting documents for a very long time. So you have tools like the Semantic Reader from the Allen AI folks. You have Andrew Head's work on contextual information about symbols in a paper, just to name two recent systems. But a key thing is these tools only work for PDFs. They are designed to operate on the document formats of old. And researchers do also build tools for the web, but they're always for these one-off environments that are enough to get you the Chi or Whist paper, but then never really see the light of day. Like, there's good ideas out there, such as these two papers about how to facilitate links between text and data. But researchers don't have any options for better platforms on which to do their research. So, what's the broader narrative here? I see these 5 points as key trends about document languages. First, technical communication is not progressing. People are still writing documents with the same tools they did 20 or even 50 years ago. Serious attempts to build better documents have proven to be prohibitively difficult for authors. It is possible to use modern GUI toolkits to produce amazing documents, but that has limited only a tiny set of people in the world. There are attempts to at least modernize our stack by moving up to the web, but these attempts are in dire straits because our old technologies are not adapting to new mediums. These new technologies being created are based, unfortunately, on the shaky foundation of Markdown, and the lack of extensibility of tools like Markdown means that research on better documents is mostly stuck making one-off prototypes. This is the story I have seen unfolding over the last 5 years. So the thesis of this talk is that the world needs a new foundation for authoring technical documents. And I think that foundation should be a programming language. A new LaTeX, a new Markdown, however you want to think about it. I have some ideas for what that foundation should look like, and the purpose of this talk is to air out these ideas in front of sharp individuals for the first time. And I want to have a discussion about whether what I'm proposing is the right way to go long term. I'm serious about building this language, and I want to design it well. So now let's dive in. To frame this discussion, I want to talk at a high level about the role of a document language in technical communication. So broadly speaking, technical documents mediate knowledge transfer. And I think about that process like this. So you start with a writer who has some knowledge, like say about the relationship between mitochondria and cells. To convey this knowledge to someone, the writer starts by sequentializing that associative knowledge into linear explanations of concepts, like mitochondrion generates energy, cell. Then the writer externalizes that knowledge into a source document like Markdown that contains some formatted natural language, like the mitochondrion is the powerhouse of the cell. The source document goes through a compiler to become a target document, like HTML. Then, a renderer displays that document to a reader. The reader internalizes that explanation by literally reading the words on the page and comprehending the sequence of ideas, and finally schematizes that linear knowledge back into associative knowledge. This model helps structure my thinking as a designer. Like my goal is to design this part, the source, target, and renderer, so as to facilitate these steps, the sequentializing, externalizing, internalizing, and schematizing of knowledge. Concretely, I think about design in terms of 3 key questions. First, what kinds of documents are most helpful for readers? How do we present information that facilitates internalizing and schematizing knowledge? Once we have an answer to that, it motivates our next question. Well, which medium is most reasonable for such documents? And once we know our target, then finally, what syntax and semantics makes those documents easy to write? And the rest of the talk will be organized around my tentative answers to each question. So first, what kind of documents are most effective for readers? Now, one way to answer this would be to look at individual instances of exemplary documents. For example, I think the Distill papers are all excellent advances in how to communicate machine learning. Like the 3-blue-1-brown channel is another incredible instance of communicating ideas across mathematics using animations. One of my personal favorites is Bartosz Ciechanowski, who has a series of blog posts about how things like GPS and car engines work. And in some sense, it's easy to look at these kinds of posts and say, okay, how do we get people to write more of stuff like this? But my first major point is I don't think looking at these exemplary documents is the best way to approach this design problem. I mean, just think about all the skills needed to produce these ideal documents. You need pedagogic skill to pick up the right examples, to build up to ideas in the right way. You need communication skill to avoid using too much jargon and to limit the cognitive load on the reader. You need visual design skill to get the perspective and color and layout and icons of everything just right. And of course, you need programming skill. Like Bartosz's web pages are literally tens of thousands of lines of manually written Canvas and WebGL code. Now, of course, we can make some of this easier, especially the programming part with better abstractions. But there's no document language that will instantly make someone as good a teacher as Bartosz or 3Blue1Brown. And so my provocation is that the next generation of document languages should aim to raise the floor of technical communication more than the ceiling. And that's done by providing high return on investment mechanisms that most writers and readers can use with relatively little training. And this argument becomes even stronger when we look at a historical perspective. This is how people wrote documents 2,000 years ago in a style called continuous script. The document is literally just a stream of letters. And now you can contrast this against my allegedly boring document I showed earlier. There's many technical innovations embedded in this paragraph. We use spaces to separate words, we use punctuation to separate clauses and sentences, we use different font faces and colors to distinguish one kind of content from another, we use capital letters to mark the beginning of a sentence. These are innovations that make at least English documents more readable, which most people can and do use every single day. So we have designed document technologies to facilitate hierarchically grouping text into words, sentences, paragraphs, sections, and chapters. And my bet is that the next document languages should focus on facilitating cross-reference, or connections between parts of a document that cross the content hierarchy. And in fact, many of these cross-reference technologies already exist today, but they exist in siloed systems that were specifically designed to support them. And I think we need to make cross-reference a commonplace aspect of every technical document in existence. So let me show you 3 cross-reference capabilities I think we need. The first is about getting additional context about concepts on demand. The most common form of this idea is a tooltip. And so here's a few good examples. Like Wikipedia shows you the pages of linked concepts in a tooltip. Andrew Head's Scholar5 system shows you the definition of mathematical symbols, or more generally, nonce words, in a tooltip. The Semantic Reader shows academic citations in a tooltip. Textbooks, like Immersive Linear Algebra, will show figures and equations in a tooltip. Whenever you are talking about something that's not visible on screen, a good document should make it trivial for you to call up that thing rather than having to commit it to memory or totally swap your reading context into a new page. Another capability is rich inline references. If you've ever used the CleverRef package in LaTeX, it's kind of like that but better. When you make a cross-reference to something, the representation of the cross-reference doesn't have to be a plain piece of hyperlinked text like section 4 or figure 5 left. One cool example is to use sparklines to represent references to data distributions on the top. Another cool example comes from this website, Burns Euclid, that walks through the proofs in Euclid's Elements. All the cross-references to geometric elements are not textual but visual, represented by an icon of the appropriate shape and color. And moreover, you can click on these and have it emphasize the corresponding part of the diagram. And then finally, cross-references should facilitate text-figure synchrony. When you're consuming text with a complex figure, then the document can automatically surface the elements of the figure that are relevant to the text. Like this is a cool example from the Washington Post. They have an article about different areas of the Ukraine. And as you scroll through the article, the map automatically updates to the relevant geographic region. Or like another example is Stripe's code documentation. They have text on the left that refers to different ranges of code on the right. And so as you scroll through the text, the figure automatically updates to emphasize the code relevant to the text. And the key idea is I think all of these interactions are achievable with very little input from authors. All an author needs to do is articulate the cross-referential structure of their document, and the document medium should be able to do the rest. I think if we can make these kinds of interactions commonplace in the documents of the world, that would represent a significant milestone in the evolution of technical communication. So, if you agree, yes, sure, we want to make these interactions commonplace, the next question is, which medium is most reasonable for documents with cross-references? By medium here, I'm referring to the rendering layer. My answer is where else but the browser, right? I don't know of any other mature cross-platform GUI toolkit that can support these kinds of interactions. It seems clear to me that the near-term future of documents is as web pages, implemented in HTML, CSS, and JavaScript. But at the same time, if you go to people and say, you don't get to read PDFs anymore, all your future documents will just be web pages, that doesn't tend to elicit a positive reaction for a lot of people. Here's a couple of reasons. One logistical issue is that PDFs are a single file, while websites are not. Websites have separate source files for HTML, CSS, and JavaScript, along with separate assets for images and fonts. Web-based documents will need some kind of standardized format that bundles all of these things into a single package. And as far as I know, that's basically the EPUB format, so that's what I'm exploring as one solution to this problem. Another issue is that PDFs preserve authorial intent for display, while websites do not. By that, I mean that readers see the exact same document that authors do. So an author can be confident that, for instance, figures are placed in just the right location, or that text flows without any widows and orphans. And I'm of two minds about this. On the one hand, I think authors need to give up a level of control over their document in order to provide flexibility to the reader. A reader should be able to change their display size or font size and have the document rearrange. But on the other hand, it is also nice to be able to say, an expert chef, this is how the dish is best enjoyed. That could be an interesting thing to encode in a document format, like the authors have verified that this document renders correctly on a 1920 by 1080 screen using Chrome version 112. Another issue is that PDFs are designed to mirror physical paper, so they look good when they're printed while websites do not. You don't want a figure, for instance, to get cut in half between two pages. And for people who like printing out documents, such as academic papers, this can be a deal breaker. But at the same time, I really don't want to be dealing with figure placement in 10 years. My hope is that we can develop sufficiently powerful heuristics for turning web pages into good-looking paper documents, or really for chunking continuous scroll documents into page-sized pieces. That way, people who want to print will get an output that looks 95% as good as a hand-tuned PDF. And finally, it's worth noting there's a huge ecosystem of reading tools that are designed to work with PDFs. The one I use for annotations is Liquid Text. There's grading tools like Gradescope. There's not really much to be done about this beyond just say it's going to take effort to update all of these tools to work with some future format. So the sooner we can coalesce around that file format, the sooner these tools would consider supporting some future web document. All right, this is obviously a big topic. The broader point is that if we are serious about having web pages be the official archival representation of technical documents, before we even get into the nitty-gritty of Markdown, we do need to resolve these basic issues first. But for now, let's assume we have a satisfactory answer to these questions, and move on to the final design challenge. What syntax and semantics would make referentially rich web documents easy to write? And now we're arriving at the core question of language design. And I'll start by putting forth my design criteria for a next-generation document programming system. First and foremost, common document elements should be easy to express. So if you're trying to write prose, styled text, paragraphs, headings, cross-references, then the action of articulating these objects into the system should be low effort. Less common elements should still be feasible to express. If something isn't baked into the language, like an arbitrary widget or some container without a special case syntax, then the language should be consciously designed around making that experience still reasonably pleasant while retaining generality. It should be possible to integrate those custom elements with the system of cross-references. So if you have a custom data visualization, then that data viz widget can define what it means to talk about it. In between these two is that my dream document language should be extensible with respect to domain-specific notations. One example would be like the math notation embodied by TeX, source code from any programming language, diagrams written in like Mermaid or TIGZ. And the emphasis here is on extensible. Like, I don't think we should be privileging specific domains over others, especially if the system is going to be used or accessible to non-computer scientists in the long term. You should be able to design a notation as a library. And then finally, I think it's really important that this document language be programmable both at compile time and runtime. So by compile time, I'm referring to, for instance, when the target code is generated. That's when you, say, interpolate variables or run your loops. And then by runtime, I mean when the renderer is showing the document, then the rendering process is programmable, either in terms of reactivity to user input or customizing the display of document elements. So these are my 4 major criteria. How do existing languages stack up against them? Well, there isn't one language that really satisfies all 4 criteria. If we write documents in HTML and JavaScript, that does not give us a concise syntax for common elements, but it does give us a general framework for writing custom elements. It doesn't really have a notion of syntactic extensibility, but it is fully programmable. We can contrast this against Common Markdown, which does make it easy to express common document elements, but doesn't satisfy any of the remaining criteria. Markdown does allow you to write HTML, but I'm not really considering that capability because the whole point of Markdown is to not write HTML. And seeing this tension, all of the recent, call them Markdown++ languages, like Quarto, Living Papers, MDX, are generally better at expressing custom elements and offering some form of programmability, but not to the extent I'm imagining. This is the problem I alluded to in the beginning when I said Markdown is a shaky foundation. Markdown itself is this really wacky language with tons of crazy edge cases, because the spec was essentially designed by grammar induction from examples. And the various Markdown successor languages kind of just glom on new syntax and features to Markdown, and the end result never really does everything you want, and it feels very fragile to use, at least in my experience. I can go through more specific examples later, but for now I want to focus on 2 specific technical design questions that are interesting to discuss. So the first challenge is I'm claiming that the main thing we should be making easier is cross-references. As a case study on this challenge, let's think about the passage from the book I've shown a few times. This passage has a code snippet and a paragraph of text talking about that snippet. And my question is, how do you express the referential structure of this passage? The idea being, if you could write down the referential structure, then your browser could, for instance, synchronize the text and the figure for a reader like I showed you with the Stripe example. And I think what we need is some notion of a document coordinate space as a way of locating objects in a document. And I'll show you some possibilities for what that means. So here's one idea. We could define this Rust code in a listing and give it an identifier, like shadow. And then whenever we refer back to it, we use the line and column numbers as references. So instead of saying this program first binds X, we say this program first binds and shadow : 2 : 7 to 8. A slight variation of this approach would be some kind of content addressable schema. So here, the listing is still the same, but the references are the content of the code being referred to. So we would say the program first binds and shadow : X_0, with this _0 being used to disambiguate which instance of X you're referring to. The upside to these 2 approaches is that the listing itself is untouched. It's just the plain source code of the program. But then these references are kind of fragile. Like if we change the source code, then the references might break. Another possibility would be to have some kind of system of overlapping annotations. So here we wrap code in the backtick paren with this colon and a number to indicate an identifier. And then inside of the prose, we say something like and shadow : 0, and that unambiguously refers to, in this case, the thing with :0 after it. This approach is nice because these labels are more stable over changes to the listing, but they also make the listing itself harder to read for the author, and they require some kind of parser to pull the annotations out of the code. One final possibility would be to pull external definitions into the listing. This is kind of similar to how Living Papers deals with references to math symbols. So if you have a definition block, like you say, x0 is x and x1 is 5 or whatever, then you can interpolate those variables into the listing, like let x at x0 equals at x1. And then the body text could simply refer to those definitions directly and x0. This is not an exhaustive list. It's just meant to show that I think there's a big diversity of approaches here. There's not one obvious correct answer for how to come up with a better system of fine-grained reference. This has deep roots too in hypertext systems like Xanadu. I think there's a lot of interesting ground to explore here. One implicit assumption I've made so far also is that we're going to be writing documents in an ASCII syntax in a code editor, right? But that's also not true for most documents. Like when you write in, say, Google Docs, we already get easy access to a document coordinate space. You can just select a range of text and add an annotation to it, like a comment. More generally, we should expect our IDE to facilitate the authoring of cross-references. But I think there's a big design question here, like, should we be designing only for the use case where users have a rich editor? Should we be designing for the use case where users use whatever text editor they want, and at best they just have syntax highlighting? If we assume users will always have a rich editor, then we could just give up entirely on a readable syntax and represent source documents as something like XML or JSON, as you might find in, say, Jupyter Notebooks. But I'm personally hesitant to go that far. Having a legible source text has a lot of benefits, such as interoperating with version control tools like Git and being an easy target for chat applications like language models. I think we should still design powerful IDEs for authoring documents, but that probably shouldn't come at the expense of considering these low-level syntactic issues. So that's one big challenge, making cross-references easy. The other one I want to talk about is programmability. So there's an open challenge for how to combine the pleasant syntax of Markdown with the computational expressiveness of something like LaTeX or JavaScript. And just to give you a sense of things that people have tried, let's say we wanted to express a document that has a list of keywords and then wants to output a paragraph that says keywords, documents, languages. This is expressible with some contortions in LaTeX and certainly in JavaScript, but it's not expressible in Common Markdown. And so people have come up with programming layers to do this sort of work on top of Markdown. Like one example is this templating system used within Pandoc. So here, if you define variables and a YAML header to your document, and then you use this $for syntax along with keywords like $it and $sep to create the keyword list. This is not, I think, a long-term solution because it's a fairly ad hoc system for a subset of document computations. Like a next-generation document language needs to be equipped with more general-purpose facilities like the ability to define abstractions. Another example is MDX, which is a variant of Markdown that supports the JSX dialect of JavaScript. So you have a JavaScript variable declaration like export const keywords at the top. And then you can interpolate an expression, which is a map of a function over the list. Now the inner function returns a React element, which is composed of the piece for the semicolon and the interpolated keyword. Now this is certainly general purpose, but the actual syntax for writing it is really gnarly. Like that's a lot of curly braces, parentheses, angle brackets, and so on for just this one simple computation. An example I really like is Typest, which is both has a general purpose programming language along with a relatively lightweight syntax. The main downside is that Typest isn't designed to generate interactive web pages. It's designed almost as like a modernized LaTeX for creating static PDFs. There are some attempts I believe there's ongoing effort to add HTML export to Typest, but it's still not clear if that's going to cover the full range of expressiveness as, say, general React or something that can express arbitrary interactive components. So I think there's still more work to be done on figuring out the right syntax that reaches the appropriate level of expressiveness that we want. So that's why I've been thinking about how to integrate JavaScript into Markdown. And I've made some progress in this area. I've designed a prototype language called Noda that extends Markdown with a lightweight syntax for putting JavaScript computation and custom elements. And this is specifically inspired by languages like Typest, as well as another one from the Racket community called Scribble. I've been working on the semantic side to really figure out also a theoretical basis for reasoning about issues like variable scoping, desugaring, type checking, and other PL-style issues. We have a paper at Popple called A Core Calculus for Documents, if you're curious about this side of things. All of this is to say, I have some relatively concrete ideas for building a programmable markdown that will make it possible to meta-program your document and handle reactivity without using too onerous a syntax. It'll just take some time to really flesh out the bones of what that will look like. Now, that roughly wraps up my high-level proposal for what I think a next-generation document language should look like. And wrapping up, going back to our list of problematic trends, I think what I'm proposing goes in a more positive direction along each of these dimensions. Like I said, technical communication is not progressing, but I believe pervasive cross-references would represent genuine progress. I said that richer documents are still inaccessible to authors, and I think that cross-references are pretty accessible to authors, especially if we can nail this coordinate space issue. I said that old technologies cannot adapt to new mediums. So let's go to this new medium. I think we should build a web-first document language that'll be much easier for doing web publishing than just converting LaTeX documents. I said that new technologies are built on the shaky foundation of Markdown, so I have a relatively clear proposal for how to solidify Markdown as a more worthy LaTeX successor. And I'm hopeful that getting these foundations right will provide a platform for researchers to design document augmentations and then see those augmentations actually get used in the wild, be it papers, blog posts, web-based textbooks, or you name it. And just wrapping up with some questions for discussion, like what are other kinds of document augmentations that you think are important to design for? This is almost a psychological question about what are the most, again, impactful things we could be doing to change how we write documents to make them more legible, more accessible to people of all different kinds of backgrounds, be they novices or experts or have various accessibility needs, that kind of thing. Is it reasonable to adopt the web/browser as the official target document format? I hand-waved a little bit over PDFs in this presentation, but I think this is a really important point because there's a lot of low-level details, even about stuff like typography, that PDFs can give you that web browsers don't. And there are trade-offs, significant trade-offs. It's not just a strict good by saying, well, everyone has to use some new format that's going to target HTML. I think we need to have a clear vision for what we are losing by moving away from PDFs. Do we need a document language or a document system? Right, this gets to my point about, for instance, should we expect people to be writing this new document thing in an editor designed for that use case, or should it have its own syntax? Is it worth putting in all this effort to create this custom syntax if we think the main use case is people will never write that syntax directly, but instead just work with it inside of something more structured? And how would we get people to adopt a new document language? Even if we come up with the world's greatest interactive document language thing, Nota++, whatever it is, it's to bootstrap adoption, we need some kind of entry point because these large institutions aren't necessarily going to swap everyone over to some new technology overnight, especially not one that's sort of more greenfield research like Nota. I'm very interested in focusing on, say, blog posts as the initial set of folks who would be open to adopting these technologies in a kind of low-stakes way. But also, I'm interested in how would you design, even if you have some sort of textual syntax that feels like programming, you still want some kind of editor that makes this all more accessible to less technical users. Like the Nota WYSIWYG editor should exist, but once you add computational features, WYSIWYG becomes a lot harder or almost sort of an unsolved problem compared to a WYSIWYG editor over Markdown, because there's a much more direct mapping between like the Markdown AST and the visualized Markdown document. But broadly, I think it's important to consider who is this document language for, and how can we increase the audience for which this would be a relevant tool for them to use. Anyways, those are just some questions to get you thinking about the future of document languages. I hope this has been an insightful, or at least thought-provoking presentation. Thanks for listening.